The next day function returns a table containing the next day, that is, the day after for each date in the current filter context. This function is often used in time intelligence scenarios where you want to perform calculations based on the next day's data, such as comparing current day values with the following day's values. Syntax: next day dates. A column that contains date values, typically from a date table. Key features of next day 1. Returns the next day's date. It shifts the date by 1 day, returning the date that is the day after each date in the filter context. 2. Used in time intelligence calculations. It is often combined with other functions like calculate to compare values between consecutive days or to calculate growth from one day to the next. 3. Works with a date table. The next day function typically uses a column from a date table to return the next day for each date in the current context. Example 1. Calculate sales for the next day. Suppose you have a sales table with sales amount and sales date, and you want to calculate the total sales for the next day based on the current filter context. Sales next day equal calculate sum sales amount next day. Date. This measure calculates the total sales for the day after the current date in the filter context. For example, if the filter context is showing sales for January 1st, this will return sales for January 2nd. Example 2. Compare current day sales to the next day. You can use next day to compare sales from the current day with sales from the next day. For instance, calculating the difference between current day sales and next day sales. Sales difference equals sum sales amount. Calculate sum sales amount. Next day date. This formula calculates the difference in sales between the current day and the next day. Example 3. Calculate the growth from one day to the next. You can also calculate the percentage growth in sales from one day to the next by comparing the current day's sales with the next day's sales. Sales growth equal divide. Calculate sum sales you next month. The next month function returns a table containing the set of dates for the next month after the given dates in the current filter context. It is a time intelligence function that is useful for calculating measures for the next month, such as predicting sales, revenue, or other metrics. Syntax: next month dates. A column that contains date values, typically from a date table. Key features of next month 1. Returns the dates for the next month. It retrieves the dates for the month that immediately follows the month in the current filter context. 2. Useful in time intelligence calculations. It's commonly used for predictive modeling, forecasting, or comparisons between current and future periods. 3. Works with calculate. It can be used in combination with calculate to compute metrics for the next month. Example 1. Total sales for the next month. Suppose you have a sales table with sales amount and sales date, and you want to calculate the total sales for the next month based on the current filter context. Sales next month equal calculate sum sales amount next month date. This calculates the total sales for the month that follows the current filter context. For example, if the current context is June, it will return the total sales for July. Example 2. Predicting revenue for the next month. You can also use next month to forecast or predict revenue for the next month. Revenue next month equal calculate sum sales revenue next month date. This calculates the total revenue expected in the next month based on the current filter context. Example 3. Applying additional filters. You can combine next month with filters to get specific results, such as calculating next month's sales for a particular region. Sales next month North America equal calculate sum sales amount next month date. Sales region equal North America. This returns the total sales for the next month, but only for the North America region. Example 4. Comparing current month to next month. You can calculate both the current month's sales and the next month's sales to compare performance. Sales current month equal calculate sum sales amount dates in period date today 1 month sales next month equal calculate sum sales amount next month date sales comparison equal sales next month sales current month. This comparison shows how sales in the current month differ from sales in the next month. Use cases. Use case 1. Forecasting the next month function is useful for creating forecasts or projections. By calculating metrics for the next month, businesses can plan for expected performance based on historical data. Use case 2. Performance comparison. You can use next month to compare current and next month's performance for metrics like sales, revenue, or expenses, helping identify growth trends or potential issues. Use case 3. Time-based reporting for dynamic reports. Next month helps in generating future-looking visuals, enabling users to track expected changes in metrics over time. Summary. The next month function returns the dates for the next month after the current filter context, making it ideal for predictive calculations and comparisons. When used with Calculate, it allows you to compute metrics like sales or revenue for the upcoming month, which is essential for forecasting and planning in business intelligence reports. Next quarter. The next quarter function returns a table containing the set of dates for the next quarter following the dates in the current filter context. It is a useful function for time intelligence calculations where you need to compute or compare data between the current quarter and the next quarter. Syntax. Next quarter dates. A column that contains date values typically from a date table. Key features of next quarter 1. Returns the next quarter's dates. It retrieves the dates for the quarter that immediately follows the quarter in the current filter context. 2. Helps in time-based forecasting. Next quarter is useful for generating forecasts, comparing metrics between quarters, or planning future activities. 3. Used with Calculate. Often combined with Calculate to compute metrics for the next quarter. Example 1. Calculate total sales for the next quarter. Suppose you have a sales table with columns, sales amount, and sales date, and you want to calculate the total sales for the next quarter based on the current filter context. Sales next quarter equal calculate sum sales amount, next quarter date. This measure calculates the total sales for the quarter following the current one. For example, if the current filter context is for Q1, this measure will calculate sales for Q2. Example 2. Forecast revenue for the next quarter. You can also use next quarter to forecast revenue for the next quarter. Revenue next quarter equal calculate sum sales revenue, next quarter date. This calculates the projected revenue for the next quarter based on the current filter context. Example 3. Apply filters for specific categories. You can refine your next quarter calculations by applying additional filters. For example, calculating sales for the electronics category in the next quarter. Sales next quarter electronics equal calculate sum sales amount, next quarter date. Sales category equal electronics. This measure calculates total sales for the electronics category in the next quarter. Example 4. Comparing current quarter sales with next quarter. You can create measures to compare sales between the current quarter and the next quarter to analyze growth or trends. Sales current quarter equal calculate sum sales amount, dates in period date today, 1 quarter. Sales next quarter equal calculate sum sales amount, next quarter date sales comparison equals sales next quarter. Sales current quarter. This comparison measure shows how sales in the current quarter compare with sales in the next quarter. Use cases. Use case 1. Forecasting future quarters. The next quarter function is valuable for forecasting revenue, sales, or other metrics for the next quarter, allowing businesses to plan for future performance. Use case 2. Quarterly performance comparison. By calculating and comparing the current quarter's metrics with the next quarter, you can analyze trends, growth rates, and potential issues that may arise in the next reporting period. Use case 3. Time-based reporting for dynamic reporting in tools like Power BI. Next quarter enables future-focused visuals, helping to display how metrics might perform in the upcoming quarter. Summary. The next quarter function is a powerful tool for calculating values for the next quarter after the current filter context. It is ideal for forecasting, quarterly comparisons, and time-based reporting. When combined with Calculate, it enables businesses to compute metrics like sales or revenue for future quarters. which helps with planning and decision-making based on projected performance. U parallel period. The parallel period function in is a time intelligence function used to return a parallel period in the past or future relative to the current filter context. You can specify the number of intervals to shift and the type of interval days, months, quarters, or years. This function is useful for comparing data across equivalent periods in previous or future time frames, such as year-over-year or quarter-over-quarter comparisons. Syntax: parallel period dates, number of intervals, interval dates. A column that contains date values typically from a date table. Number of intervals. The number of intervals to shift. Positive values shift forward, and negative values shift backward. Interval. The type of interval to use. This can be day, month, quarter, year. Key features of parallel period 1. Shifts by a defined period. It allows you to shift the time context by a specific number of intervals: days, months, quarters, or years. 2. Returns parallel periods. It is often used to compare equivalent periods, such as the same quarter last year or the same month in the previous year. 3. Works with time intelligence. The function is commonly used for time-based comparisons such as year-over-year growth or period-to-period analysis. Example 1. Year-over-year sales comparison. Suppose you have a sales table with columns sales amount and sales date. You want to calculate the total sales for the same period 1 year ago. Sales parallel period year equal calculate sum sales amount parallel period date 1 year. This measure shifts the time context back by 1 year and calculates the total sales for the same period last year. Example 2. Quarter-over-quarter sales comparison. To compare the current quarter's sales with the same quarter in the previous year, you can shift the time context by 1 quarter. Sales parallel period quarter equal calculate sum sales amount parallel period date 1 quarter. This shifts the time context to the previous quarter, allowing you to compare the sales between the current and previous quarters. Example 3. Month-over-month comparison. You can use parallel period to compare data between months. For instance, calculating total sales for the same month in the previous year. Sales last year some month equal calculate sum sales amount parallel period date 12 month. This measure shifts the time context back by 12 months, allowing you to compare the current month's sales with the sales from the same month last year. Example 4. Custom time period comparison. Parallel period is flexible and can be used to shift by a custom number of periods. For example, if you want to calculate total sales for 3 quarters ago, sales 3 quarters ago equal calculate sum sales amount parallel period date 3 quarter. This measure shifts the time context back by 3 quarters and returns the total sales for that period. Difference between parallel period and other time intelligence functions. Parallel period versus same period last year. Same period last year specifically returns the same period exactly 1 year ago, keeping the same range of days, months, or quarters. Parallel period is more flexible, allowing you to shift by any number of periods: years, quarters, months, days forward or backward. Parallel period versus date add. Date add also shifts the time context, but it is more granular, as it allows shifting by smaller increments like days. Parallel period focuses on larger intervals, such as months, quarters, or years, making it easier for period-based comparisons. Use cases. Use case 1. Year-over-year growth. Parallel period is commonly used for calculating year-over-year growth by shifting the context by 1 year and comparing the same period. YoY growth equal divide sum sales amount. Calculate sum sales amount parallel period date 1 year. Calculate sum sales amount parallel period date 1 year. This formula calculates the growth percentage by comparing the current year's sales with the same period in the previous year. Use case 2. Quarter-over-quarter analysis in financial or sales reports. You may want to analyze quarter-over-quarter performance, making parallel period useful for comparing the current quarter with previous quarters. Use case 3. Period-based forecasting. Businesses can use parallel period to generate future forecasts by shifting the time context forward and using historical data to predict future performance. Summary: the parallel period function is a powerful tool for comparing data across equivalent periods, such as the same month, quarter, or year in the past or future. It allows you to shift the time context by a specified number of intervals, making it flexible for various time intelligence scenarios. It is ideal for year-over-year, quarter-over-quarter, or month-over-month comparisons, as well as for forecasting and tracking trends. Previous day. The previous day function is a time intelligence function used to return a table containing the dates for the previous day relative to the current filter context. This function is particularly useful when you need to calculate metrics or make comparisons with data from the day before the current date in the context. Syntax: previous day dates. A column that contains date values, typically from a date table. Key features of previous day 1. Returns the previous day's date. It retrieves the date for the day before the current filter context. 2. Useful for daily comparisons. Often used for comparing metrics between consecutive days, such as yesterday's sales or daily performance trends. 3. Works with calculate. Typically combined with calculate to compute values for the previous day. Example 1. Calculate sales for the previous day. Suppose you have a sales table with columns sales amount and sales date. You can calculate the total sales for the previous day using previous day as follows. Sales previous day equal calculate sum sales amount previous day date. This measure calculates the total sales for the day before the current date in the filter context. For example, if today is January 2nd, this will calculate sales for January 1st. Example 2. Compare sales between current day and previous day. You can use previous day to compare sales between the current day and the previous day. For instance, calculating the difference in sales between today and yesterday. Sales comparison equals sum sales amount. Calculate sum sales amount previous day date. This formula calculates the difference between the current day's sales and the sales from the previous day. Example 3. Sales growth from the previous day. You can also calculate the percentage growth in sales between today and yesterday by comparing the sales amounts. Sales growth equal divide sum sales amount. Calculate sum sales amount previous day date. Calculate sum sales amount previous day date. This formula calculates the sales growth from the previous day by comparing today's sales with the previous day's sales. Example 4. Previous day sales with additional filters. You can apply filters along with previous day. For example, to calculate previous day's sales for a specific product category. Sales previous day electronics equal calculate sum sales amount previous day date. Sales product category equal electronics. This calculates the total sales for the electronics category on the previous day. Use cases. Use case 1. Daily performance tracking. Previous day is often used for tracking daily performance trends. For instance, calculating and comparing sales or revenue for today and yesterday helps businesses monitor daily progress. Use case 2. Daily growth and decline analysis. By calculating the percentage change between today's and yesterday's data, businesses can quickly identify areas of growth or decline, helping them make informed decisions. Use case 3. Time-based reporting in reports or dashboards. Previous day is used to create time-based insights, such as showing how key metrics, sales, revenue, or expenses change from day to day. Summary: the previous day function is a valuable tool for daily time intelligence calculations, allowing you to compare data from the current day with data from the previous day. It is useful for analyzing daily trends, monitoring performance, and calculating day-over-day growth or changes. When combined with calculate, it provides the flexibility to compute various metrics based on the previous day's data, making it essential for daily reporting and analysis in Power BI and other based platforms. Previous day. The previous day function in is a time intelligence function that returns a table containing the set of dates for the day before the current filter context. This function is commonly used when you need to perform calculations or comparisons based on the previous day's data, such as calculating yesterday's sales or measuring the day-over-day change. Syntax: previous day dates. A column containing date values, typically from a date table. Key features of previous day 1. Returns the previous day. It retrieves the date of the day before the current date in the filter context. 2. Works with time intelligence. Useful for daily comparisons, such as tracking day-over-day metrics. 3. Combines with calculate. Commonly used with calculate to compute values for the previous day. Example 1. Calculate sales for the previous day. Suppose you have a sales table with columns sales amount and sales date, and you want to calculate total sales for the previous day. Sales previous day equal calculate sum sales amount previous day date. This measure calculates the total sales for the day before the current date in the filter context. For example, if today is July 15, this will return sales for July 14. Example 2. Compare sales between today and previous day to compare current day sales with previous day sales. You can use previous day to find the difference. Sales difference equals sum sales amount. Calculate sum sales amount. Previous day date. This measure calculates the difference between today's sales and yesterday's sales. Example 3. Calculate growth from the previous day. You can also calculate the percentage growth in sales from yesterday to today. Sales growth equal divide sum sales amount. Calculate sum sales amount. Previous day date. Calculate sum sales amount. Previous day date. This formula computes the sales growth by comparing today's sales to yesterday's sales. Example 4. Apply filters with previous day. You can use previous day along with filters to calculate previous day metrics. Use start of month. The start of month function in returns the first date of the month in the current filter context for a given column of dates. This function is useful for time intelligence calculations where you need to compute metrics as of the first day of the month, such as month-to-date calculations or comparisons across months. Syntax: start of month dates. A column that contains date values, typically from a date table. Key features of start of month 1. Returns the first date of the month. It retrieves the first date in the current month, which is useful for month-to-date calculations and comparisons. 2. Helps in time-based reporting. Commonly used for reports that track metrics from the start of a month. 3. Works with calculate. Frequently used with calculate to aggregate data starting from the first day of the month. Example 1. Get the first date of the month. Suppose you have a date table and you want to return the first date of the month based on the current filter context. First day of month equals start of month date. This will return the first date of the month based on the current filter context. For example, if the filter context is February 2023, it returns February 1st, 2023. Example 2. Calculate sales from the start of the month. If you have a sales table with columns sales amount and sales date, and you want to calculate total sales from the start of the month, you can use start of month with calculate. Sales from start of month equal calculate sum sales amount. Date equals start of month date. This measure calculates the total sales starting from the first day of the month up to the current date in the filter context. Example 3. Month-to-date sales. You can also use start of month to create a month-to-date (MTD) calculation by summing sales from the start of the month to the current date. Sales MTD equal calculate sum sales amount. Dates between date, start of month date. Today. This measure calculates the total sales from the start of the current month up to today. Example 4. Compare sales from the start of the current and previous month. You can use start of month along with other functions like same period last year to compare sales from the start of the current month to the same period last year. Sales from start current month equal calculate sum sales amount. Date equals start of month date. Sales from start last year month equal calculate sum sales amount. Date equals start of month, same period last year, date. This measure compares sales from the start of the current month with sales from the start of the same month last year. Use cases. Use case 1. Month-to-date reporting. Start of month is frequently used to calculate month-to-date MTD metrics. For example, companies often track MTD sales, revenue, or other key metrics to monitor progress during the month. Use case 2. Monthly comparisons. By using start of month, you can compare key metrics between the beginning of the current month and previous months, allowing for detailed time-based analysis. Use case 3. Time intelligence reporting in Power BI reports. Start of month helps in creating visuals and tables that display how data accumulates from the start of a month or resets at the beginning of each month. Summary. The start of month function returns the first date of the month for a given column of dates. It is essential for time intelligence calculations, especially when calculating month-to-date values, comparing metrics between different months, or performing month-based reporting. When combined with Calculate, it provides flexibility in tracking metrics from the beginning of the month, making it valuable for time-based performance analysis and reporting. Use start of year. The start of year function returns the first date of the year in the current filter context for a given column of dates. This function is particularly useful for time intelligence calculations that involve year-to-date YTD metrics, or when you need to compare metrics starting from the first day of the year. Syntax. Start of year dates. Year-end date dates. A column that contains date values typically from a date table. Year-end date optional. An optional parameter that specifies the custom fiscal year-end date. If omitted, the default is December 31. Key features of start of year 1. Returns the first date of the year. It returns the first day of the year based on the current filter context. 2. Used for year-to-date YTD calculations. It is commonly used in YTD metrics, helping businesses track cumulative performance from the start of the year. 3. Supports fiscal years. You can specify a custom fiscal year end date, making the function flexible for both calendar and fiscal year reporting. Example 1. Get the first date of the year. Suppose you have a date table and you want to find the first day of the year based on the current filter context. First day of fire equals start of year date. This returns the first date of the year based on the filter context, for example, January 1st, 2023, if the current year is 2023. Example 2. Calculate year-to-date YTD sales. If you have a sales table with sales amount and sales date, and you want to calculate year-to-date YTD sales starting from the first day of the year, you can use start of year with Calculate. Sales YTD equal calculate sum sales amount, dates between date, start of year date. Today, this measure calculates total sales from the start of the year up to today YTD sales. Example 3. Fiscal year start date. If your organization operates on a fiscal year that does not align with the calendar year, you can specify a custom fiscal year end date. For example, if your fiscal year ends on June 30, the first day of the fiscal year would be July 1. First day fiscal year equals start of year date 06/30. This returns July 1 as the first day of the fiscal year, based on a fiscal year ending on June 30. Example 4. Comparing year-to-date performance with the previous year, you can use start of year to compare YTD sales between the current year and the previous year. Sales YTD current year equal calculate. Sum sales amount, date equals start of year, date sales YTD last year equal calculate sum sales amount, date equals start of year same period last year, date. This calculates YTD sales for both the current year and the previous year, allowing you to compare performance between the two periods. Use cases. Use case 1. Year-to-date YTD reporting. Start of year is commonly used to calculate YTD metrics, such as sales, revenue, or expenses, helping organizations track cumulative performance from the start of the year to the current date. Use case 2. Fiscal year reporting. If your organization follows a fiscal year rather than a calendar year, You can use start of year with a custom fiscal year end date to compute metrics from the start of the fiscal year. Use case 3. Time-based reporting in Power BI reports. Start of year helps build visuals and tables that display cumulative values from the beginning of the year, making it easier to track performance over time. Summary: the start of year function in is a key time intelligence function used to return the first date of the year, based on the current filter context. It is essential for year-to-date calculations, allowing users to track cumulative performance from the start of the year. With support for fiscal years through the optional year-end date parameter, start of year is highly flexible and is commonly used for both calendar and fiscal year reporting in business intelligence tools like Power BI. UCalendar, the calendar function in is used to generate a table of dates, returning a single column table containing a continuous range of dates. The function requires a start and end date as inputs and is commonly used to create custom date tables in Power BI for time-based analysis. Syntax: calendar start date, end date, start date. A scalar value representing the first date in the date range. This can be a fixed date or an expression that returns a date. End date: a scalar value representing the last date in the date range. This can also be a fixed date or an expression that returns a date. Key features of Calendar 1. Generates a continuous range of dates. It returns a single column table with a list of dates starting from start date and ending at end date. 2. Useful for custom date tables. It is often used to create a date table for time intelligence calculations, providing a continuous range of dates that can be linked to other tables. 3. Works with dynamic date ranges. You can use dynamic expressions to define the start and end dates, making it flexible for different reporting needs. Example 1. Create a simple date table. Suppose you want to create a date table for the year 2023. You can use the calendar function to generate the dates from January 1st, 2023 to December 31st, 2023. Dateable equal calendar date 2023 1 date 2023 12/31. This creates a table with all the dates from January 1st, 2023 to December 31st, 2023. Example 2. Create a date table for multiple years. If you want to create a date table spanning multiple years, such as from January 1st, 2020 to December 31st, 2025, you can do so by defining the start and end dates. Dateable equal calendar date 2020 1 date 2025 12/31. This generates a table with all the dates from January 1st, 2020 to December 31st, 2025. Example 3. Use dynamic dates for start and end. You can use dynamic expressions to define the start and end dates. For example, if you want the start date to be January 1 of the earliest year in the sales table and the end date to be December 30 1 of the latest year in the sales table. Dateable equal calendar min sales date max sales date. This creates a date table that dynamically adjusts to the date range in the sales table based on the earliest and latest dates in that column. Example 4. Creating a fiscal year calendar. If your organization uses a fiscal year starting in July, you can use the calendar function to create a table for fiscal years. For example, UCalendorado calendar and Calendorado are two functions in use to generate tables of dates. They are primarily used for creating date tables, which are essential for performing time intelligence calculations in Power BI, Power Pivot, or other base tools. Calendar function. The calendar function creates a table of dates between a specified start date and end date. It's a useful way to generate a date table when you know the exact date range you need. Syntax: calendar start date, end date, start date, the first date in the range, end date, the last date in the range. Key features of Calendar 1. Manual date range. You specify both the start and end date. 2. Useful for static date ranges. It's commonly used when you have a predefined date range in your dataset. 3. Works with time intelligence. A generated calendar table can be used in conjunction with time intelligence functions. Example 1. Generate a calendar table. Suppose you want to create a date table with dates from January 1st, 2020 to December 31st, 2023. Dateable equal calendar date 2020 1 date 2023 12/30 1. This creates a table with all dates between January 1st, 2020 and December 31st, 2023. Example 2. Dynamic calendar based on min and max dates. You can dynamically generate a date range using the minimum and maximum dates from your data model. Dateable equal calendar min sales date max sales date. This dynamically generates a date table based on the first and last dates from the sales date column. Calendorado function. The Calendorado function automatically creates a date table based on the minimum and maximum date values found in your entire data model. It is a convenient way to create a date table without manually specifying the date range. Syntax UDateDiff. The dateDiff function calculates the difference between two dates in terms of days, months, quarters, or years. It returns an integer representing the time difference between the two dates, which makes it useful for date-based calculations such as finding the duration between two events or comparing time spans. Syntax dateDiff start date, end date, interval start date. The earlier date in the range, typically a column or date expression. End date. The later date in the range, typically a column or date expression. Interval. The unit of time to measure the difference. The available interval options are day, month, quarter, year, hour, minute, second. Key features of dateDiff 1. Calculates time differences. Returns the difference between two dates in days, months, quarters, or years, depending on the interval specified. 2. Useful in time-based comparisons. Allows you to calculate the duration between events, such as time to purchase, tenure, or age. 3. Flexible with different time intervals. The function can compute differences at various granularities from days to years. Example 1. Days between two dates. Suppose you have a sales table with order date and ship date, and you want to calculate the number of days it took for orders to be shipped. Shipping duration days equal date, diff sales order date, sales ship date, day. This calculates the number of days between the order date and ship date for each row. Example 2. Months between two dates. If you want to calculate the number of months between a customer's registration date and today, you can use months since registration equal date, diff customer's registration date, today, month. This calculates how many months have passed since the customer's registration. Example 3. Years between two dates. To calculate the number of years between two dates, such as the difference between an employee's hire date and today. Years of service equal date, diff employee's hire date, today, year. This returns the number of years the employee has worked based on the hire date. Example 4. Age calculation in years. To calculate UDateDiff function. In the dateDiff function, it calculates the difference between two dates and returns the result as a number. You can specify the unit of time, days, months, quarters, or years in which you want the result. Syntax dateDiff start date, end date, interval start date, the starting date, end date, the ending date, interval, the unit of time in which the difference should be calculated. Options are day, difference in days, month, difference in months, quarter, difference in quarters, year, difference in years. Example 1. Difference in days. If you have two date columns, order date and ship date, and you want to calculate the number of days between them. Days difference equal dateDiff sales order date, sales ship date, day. This will return the difference between order date and ship date in days. Example 2. Difference in months. If you want to calculate the difference between two dates in months, months difference equal dateDiff sales order date, sales ship date, month. This will return the difference between order date and ship date in months. Example 3. Difference in years. To calculate the difference in years between two dates. Years difference equal dateDiff sales order date, sales ship date, year. This will return the difference between order date and ship date in years. Day function. In the day function, it extracts the day from a date value. UEDate. The eDate function returns the date that is a specified number of months before or after a given start date. This function is useful when you need to calculate a future or past date by shifting the date by a certain number of months. It works with both positive and negative integers, which determine the direction of the date shift. Syntax: eDate start date, month start date, a date from which the calculation starts. Months: the number of months to add or subtract. Positive values add months, and negative values subtract months. Key features of eDate 1. Shifts dates by months. It adds or subtracts a specific number of months from a given start date. 2. Useful for time-based calculations. Commonly used to calculate expiration dates, installment schedules, or projects deadlines. 3. Works with both positive and negative values. Positive values move the date forward, and negative values move the date backward. Example 1. Adding months to a date. Suppose you have a sales table with a sale date column, and you want to calculate the date 3 months after the sale. 3 months later equal eDate sales sale date. 3. This adds 3 months to each date in the sale date column, returning a new date 3 months later. Example 2. Subtracting months from a date. If you want to calculate the date 6 months before the sale, 6 months earlier equal eDate sales sale date. 6. This subtracts 6 months from each date in the sale date column, returning the date 6 months earlier. Example 3. Calculate expiration date. For calculating an expiration date that is 12 months after a product's registration date. Expiration date equal eDate product registration date. 12. This returns the expiration date 12 months after the registration date. Example 4. Dynamic date calculation. You can use dynamic calculations with eDate. For example, to calculate the next due date for a subscription starting from today and adding 6 months. Next due date equal eDate today, 6. This calculates the date that is 6 months from today's date. Use cases. Use case 1. Loan repayment schedules in finance. eDate can be used to calculate payment due dates for a loan repayment schedule, where payments are made monthly or quarterly. Use case 2. Subscription renewal dates. For businesses that deal with subscriptions, eDate can calculate the renewal date by adding a specific number of months to the subscription start date. Use case 3. UEO month. The EO month function returns the last day of the month for a given date, either in the current month or a specified number of months before or after the date. This function is useful for calculating month-end dates and can be used for a variety of time intelligence calculations, such as determining month-end balances or calculating the end date of fiscal periods. Syntax: EO month start date, month start date, a date from which the calculation starts. Months: an integer representing the number of months to shift the date. Positive values return a future month, while negative values return a past month. Key features of EO month 1. Returns the last date of a month. This function gives you the last day of a month based on the starting date and the number of months shifted. 2. Supports both future and past months. The months parameter can shift forward or backward in time by a specified number of months. 3. Useful for month-end calculations. It's commonly used in financial reporting and month-end closing processes. Example 1. Last day of the current month. To find the last day of the current month based on a date in the sales date column. End of current month equal EO month sales date. 0. This returns the last day of the month for the date in sales date. Example 2. Last day of the next month. To calculate the last day of the next month. End of next month equal EO month sales date. 1. This returns the last day of the month for the month following the month of sales date. Example 3. Last day of the previous month. To find the last day of the previous month. End of previous month equal EO month sales date. 1. This returns the last day of the month for the month before sales date. Example 4. Calculate month-end balance. If you want to calculate the month-end balance for a financial report, you could use the month function to find the last day of the month for reporting purposes. Month-end balance equal calculate sum balances amount balances date equal month today 0. This calculates the balance as of the last day of the current month. Use cases. Use case 1. Month-end reporting. Full month is frequently used in financial reports to calculate month-end values such as balances, revenue, or inventory. Use case 2. Month-based comparisons. You can use month to compare month-end figures across different months or years by shifting the date using the months parameter. Use case 3. Dynamic date calculations in dynamic reports. month is useful for calculating future or past month-end dates, helping create visuals or tables that adjust based on the reporting period. Summary: the month function is a powerful tool for calculating the last day of a month based on a specific date. It is commonly used in time intelligence calculations for financial reporting, where knowing the month-end date is critical for generating accurate reports. With the ability to shift forward or backward by a specified number of months, month is flexible for various use cases involving month-end dates. Hour 3 more day. The day function is used to extract the day of the month from a given date. It returns an integer between 1 and 31, representing the day component of the date. Syntax: day, date, date. A date or a column containing date values from which you want to extract the day. Key features of day 1. Extracts the day from a date. The function returns the day portion of the date as an integer 1 to 31. 2. Useful for date-related calculations. It's often used when you need to filter or calculate values based on the day of the month. Example 1. Extract the day from a date column. Suppose you have a sales table with a sales date column. You want to extract the day from each sales date. Sales day equal day sales date. This will return the day part of the sales date for each row, such as 1 for January 1st or 15 for January 15th. Example 2. Filtering data based on day. If you want to calculate total sales that occurred on the 15th of any month, you can use the day function. Sales on 15th equal calculate sum sales amount. Day sales date equal 15. This measure calculates total sales where the day of the sales date is the 15th. Example 3. Calculate day of today. You can use the day function with today to get the current day of the month. Current day equal day today. This will return the current day of the month based on today's date. Use cases. Use case 1. Filtering by day. You can use the day function to filter or calculate values for specific days of the month, such as calculating all sales that occurred on the first day of every month. Use case 2. Calculating days left in a month. You can use day along with other functions to calculate how many days are left in the current month by subtracting the current day from the total number of days in the month. Summary: the day function is a simple but powerful tool for extracting the day portion from a date. It is commonly used in time intelligence calculations to filter data based on specific days, as well as in dynamic date calculations for reports. Hour. The hour function is used to extract the hour from a given time or daytime value. It returns an integer representing the hour component, which ranges from 0 to 23. This function is useful when you need to analyze or filter data based on the hour of the day. Syntax: hour, daytime, datetime. A column or expression that contains a time or daytime value. Key features of hour 1. It extracts the hour from a time or daytime. It returns the hour as an integer 0 to 23. 2. Useful for time-based analysis. It is commonly used to filter or group data based on hours of the day. Example 1. Extract the hour from a daytime column. Suppose you have a sales table with a sales timestamp column, and you want to extract the hour when each sale occurred. Sales hour equal hour sales timestamp. This will return the hour component of the sales timestamp for each row, such as 14 for 2 o'clock. Example 2. Filter data by specific hour. If you want to calculate the total sales that occurred during a specific hour, such as between 9 a.m. and 10 a.m., You can use the hour function. Sales 9. M = calculate sum sales amount, hour sales timestamp equal 9. This measure calculates the total sales that occurred at 9 a.m. Example 3. Calculate current hour. You can use hour along with the now function to extract the current hour. Current hour = hour now. This will return the current hour based on the system time. Use cases. Use case 1. Time-based grouping hour is commonly used to group data based on the hour of the day. For example, you can group sales or traffic data by the hour to identify peak hours of activity. Use case 2. Filtering by specific hour. You can use hour to filter or analyze data for specific hours of the day, such as calculating sales during business hours or identifying late-night transactions. Summary: the hour function extracts the hour from a time or daytime value, returning a number between 0 and 23. It is useful for time-based analysis, such as grouping data by hour or filtering data based on specific hours of the day. When combined with functions like calculate and now, it allows for dynamic and powerful time-based reporting. The window function is a newer function designed to provide advanced windowing or partitioning functionality for calculations. It allows you to apply aggregations or calculations across a subset window of a dataset rather than the entire dataset. This is useful for advanced analytics, such as calculating running totals, moving averages, and other similar calculations. Syntax: window start, end, partition by, order by start. The starting point of the window, for example, the first row in the window. End. The ending point of the window, for example, the last row in the window. Partition by optional. Defines the partitioning of the data set, for example, how to group the data. Order by optional. Specifies how the data within the window should be ordered. Key features of Window 1. Window-based calculations. It enables advanced window-based analytics such as running totals, moving averages, ranking, and other metrics. 2. Flexible partitioning and ordering. The function allows you to partition and order your dataset to apply specific calculations over custom-defined windows. 3. Useful for complex time and sequence analysis. You can calculate measures over a sliding or fixed window, such as sales over the last 3 months or ranking sales across different regions. Example 1. Moving average. Suppose you want to calculate a 3-month moving average of sales for each month. You can use window to define a window of 3 months for each calculation. Moving average 3 months = average x window 2, 0, all sales date, order B sales date, ASC sum sales amount. This returns the average sales over the current month and the 2 preceding months. Example 2. Running total. To calculate a running total of sales, you can use window to create a cumulative sum up to the current row. Running total = sum x window first, current, all sales date, order B sales date, ASC sum sales amount. This accumulates the sales from the first row up to the current row, creating a running total. Example 3. Ranking within a partition. If you want to rank sales within each region, you can partition the dataset by region and then order the data by sales within each partition. Sales rank = ranks window first, current, partition B sales region, order B sales amount. DAX sales amount. This will rank the sales within each region, with the highest sales getting the highest rank. Use cases. Use case 1. Moving averages and smoothing. The window function can be used to create smooth moving averages over a period of time, helping to identify trends in time series data. Use case 2. Ranking within groups. Window is useful when you need to rank or aggregate data within specific partitions or groups, such as ranking employees by performance within each department or region. Use case 3. Running totals. Running totals are common in financial reporting and can easily be calculated using window, providing cumulative sums over a range of data. Summary. The window function is designed for you range The range function is used to define a subset or range of rows or data points from a larger dataset, making it useful in window functions and advanced analytics. While there isn't a native range function specifically in some window-based and time-based functions like dates between, dates in period, or offset achieve similar results by defining a range of dates or data points. Key functions for range-based calculations: 1. Dates between returns a range of dates between two specific dates. 2. Dates in period returns a range of dates from a start date, extending forward or backward by a specified number of days, months, quarters, or years. 3. Offset, a new feature and allows you to define a row offset, moving forward or backward by a specified number of rows. Example 1. Using dates between to define a date range. If you want to calculate total sales between two specific dates, you can use dates between to define the range. Sales between dates equal calculate sum sales, sales amount, dates between date 2023, 1, 1, date 2023, 12, 31. This calculates the total sales between January 1st, 2023 and December 31st, 2023. Example 2. Using dates in period to define a range of dates to calculate sales in the last 90 days from a given date. You can use the dates in period function. Sales last 90 days equal calculate sum sales, sales amount, dates in period date. Today, 90 day. This defines a range of 90 days prior to the current date today and calculates the sales within that period. Example 3. Using offset for row-based calculations, offset allows you to shift rows forward or backward in a table. For instance, to compare the current row's sales to the previous row's sales, you can use offset. Sales comparison equals sum x offset 1, all sales sales date, order B sales sales date, ASC sales sales amount. This compares the current row's sales with the previous row's sales by defining a range of one rows before the current context. Use cases. Use case 1. Time-based calculations. You can use functions like dates between or dates in period to define a time range, such as calculating sales over a specific time period or comparing performance over consecutive periods. Use case 2. Row-based ranges. The offset function helps in creating ranges of rows, allowing you rank. The rank function is used to return the rank of a specific value within a dataset. It can rank values in either ascending or descending order, and it's commonly used in reporting to rank metrics like sales, revenue, or other key performance indicators within a group, for example, by region, product, or department. The rank X function is typically used to perform ranking operations. Syntax of rank X table, expression, value, order, ties table. The table over which the ranking will be calculated. This could be the result of a filter or an entire table. Expression. The expression that evaluates to the value being ranked, for example, sum of sales. Value optional. The specific value that you want to rank. If not provided, it defaults to the current row context. Order optional. The sorting order. Use 0 for descending default, or 1 for ascending. Ties optional. How ties should be handled. Options are skip default or dense ranking. Skip skips rank numbers for tied values, while dense assigns the same rank to ties but doesn't skip subsequent ranks. Key features of rank X1. Flexible ranking. You can rank values in ascending or descending order. 2. Handles ties. You can control how ties are handled, with either dense or skip ranking. 3. Customizable expressions. The function can rank complex expressions or calculations, making it versatile for a wide range of ranking scenarios. Example 1. Rank sales by product. Suppose you have a sales table with columns product and sales amount. To rank products by total sales in descending order, you can use the rank X function. Product rank equal rank X all sales product, sum sales sales amount, 0. This ranks each product based on total sales, with the product with the highest sales receiving rank of 1. Example 2. Rank by sales in ascending order. If you want to rank products by total sales in ascending order, that is, lowest sales get the highest rank. Product rank ascending equal rank X all sales product, sum sales amount, 1. This ranks products with the lowest sales as rank 1. Example 3. Dense ranking with ties. If you want to rank sales by product and handle ties using dense ranking where tied values get the same rank, but subsequent values don't skip ranks. Dense a product rank equal rank X, all sales product, sum sales amount, 0. Dense. In this example, products with the same sales will receive the same rank, but the next product will follow directly after, without skipping ranks. Example 4. Rank sales by region. If you want to rank sales by region, you can partition the ranking by region, meaning that each region will have its own ranking. Rank per region equal rank X filter sales, sales region equal earlier sales region, sum sales amount, 0. This ranks products within each region based on sales, where the highest sales in each region receive rank 1. Use cases. Use case 1. Ranking products by sales. You can rank products, customers, or regions based on sales or other metrics to identify the top performing or lowest performing entities. Use case 2. Ranking with multiple criteria. You can combine rank X with complex expressions to rank items based on multiple criteria, such as ranking customers by both the number of orders and total purchase value. Use case 3. Handling ties and rankings. You can control how ties and values are treated, either skipping ranks skip or using dense ranks dense, depending on the report's needs. Summary. The rank X function in is a powerful tool for calculating ranks within a dataset. It allows you to rank values in ascending or descending order and provides flexibility in handling ties and filtering or partitioning data for specific ranking requirements. Whether you need to rank products, regions, or customers, RankX provides a robust solution for advanced ranking scenarios in Power BI and other based platforms. Cross-filter. The cross-filter function in is used to modify the direction of cross-filtering between two related tables. It allows you to control the behavior of bidirectional or single-directional relationship within a calculation, making it highly useful in scenarios where you want to override the default relationship behavior in your data model. This function is often employed in complex data you related. The related function in is used to retrieve a value from a related table. It enables you to access columns from another table that is connected to the current table through a relationship in your data model. This function is commonly used in calculated columns or measures to reference fields from related tables without needing to explicitly join tables, as relationships are already defined in the model. Syntax related column. A column from a related table that you want to retrieve values from. Key features of related 1. Accesses data from related tables. It fetches a value from a related table using an existing relationship. 2. Works with one-to-many and many-to-one relationships. It can be used in scenarios where the current table has a direct relationship, either one-to-many or many-to-one with the target table. 3. Simplifies data access. It allows you to avoid manual joins in by leveraging the relationships already set in the data model. Example 1. Retrieve product name from a related table. Suppose you have two tables, sales and products. The sales table has a producted column, and the products table has a product name column. If there is a relationship between sales producted and products producted, you can retrieve the product name for each sale using the related function. Product name equal related products product name. This will return the name of the product for each row in the sales table by looking it up in the products table. Example 2. Calculate sales amount by unit price from a related table. If you want to calculate the total sales amount in the sales table using the unit price column from the products table, you can use the related function to access the unit price for each product. Sales amount equals sales quantity related product unit price. This will calculate the total sales amount for each row in the sales table by multiplying the quantity sold by the unit price from the related products table. Example 3. Access customer information from a related table if you have a sales table and a related customers table with customer details. For example, customer name. You can use the related function to retrieve the customer name for each sale. Customer name equal related customers. Customer name this will bring the customer's name into the sales table, assuming there is a relationship between sales customer and customers customer. Use cases. Use case 1. Bringing related data into the current table. Related is commonly used to bring data from a related table into the current context. For example, you might need to pull product information into the sales table for further calculations. Use case 2. Combining data from multiple tables in complex reports. Related helps you combine data from multiple tables, such as combining sales and product information without having to manually join tables in. Use case 3. Creating calculated columns. You can use related in calculated columns to create new fields that are dependent on values from a related table. For instance, calculating the total sales amount or retrieving additional information for each row in the current table. Summary. The related function allows you to access values from related tables in your data model by leveraging existing relationships. It is particularly useful for simplifying calculations and making cross-table references in a seamless way without the need for manual joins. Whether you are retrieving product names, customer information, or calculating metrics based on related data, related is a key function for working with relationships in your related table. The related table function returns a table that contains all rows from a related table based on the current row context in the current table. It allows you to bring in an entire related table into a formula, enabling you to apply calculations on the related data. Unlike related, which retrieves a single value from a related table, related table retrieves multiple rows that are related to the current table. Syntax. Related table table. The related table from which to return rows. Key features of relatable 1. Returns all related rows. It retrieves a full table of related rows rather than a single value, making it useful for applying aggregations on related data. 2. Works with many-to-one and one-to-many relationships. The function retrieves all rows from the related table based on the existing relationships in the data model. 3. Useful for aggregations. You can apply functions like sum, count, or average on the return table for aggregated calculations. Example 1. Summing related sales. Suppose you have two tables, products and sales. You want to calculate the total sales amount for each product by summing the related sales rows from the sales table. You can use related table to bring in all the related sales rows for each product and then sum the sales amount. Total sales for product equals sum x related table sales amount. This measure calculates the total sales for each product by summing the sales amount from the related sales table for each product in the products table. Example 2. Count related orders for each customer. Assume you have a customers table and a related orders table. You want to count how many orders each customer has placed. Using related table, you can retrieve all related rows from the orders table and count them. Order count equal count rows related table orders. This measure calculates the number of orders each customer has placed by counting the related rows from the orders table for each customer in the customers table. Example 3. Average order value per customer. You can use related table to calculate the average order value for each customer by retrieving the related orders and calculating the average order value. Order value equal average x related table orders order value. This measure calculates the average order value for each customer by taking the average of the order value from the related orders table. Use cases. Use case 1. Aggregating related data. Related table is useful when you need to perform aggregations on related data, such as summing sales amounts, counting related records, or calculating averages. Use case 2. Working with one-to-many relationships in cases where the current table has a one-to-many relationship with another table. Related table enables you to bring in the related rows and apply calculations like totals or averages. Use case 3. Filtering and applying calculations. You can use related table in combination with other functions like filter or calculate to apply more advanced filtering and calculations based on related data. Summary: the related table function in is used to retrieve all rows from a related table based on the current row context. It is particularly useful for aggregating data, such as summing or counting related rows, and works with many-to-one and one-to-many relationships. Unlike the related function, which brings in a single value, related table allows you to work with multiple related rows, making it ideal for advanced calculations in Power BI, Power Pivot, or other enabled platforms. You use relationship. The use relationship function in is used to activate an inactive relationship between two tables within a specific calculation. In a data model, multiple relationships can exist between tables, but only one is active at a time. The use relationship function allows you to switch between active and inactive relationships on a case-by-case basis for calculations, without modifying the data model itself. Syntax: use relationship column 1, column 2, column 1. The first column from one table that is part of the relationship. Column 2. The second column from the related table that is part of the relationship. Key features of use relationship 1. Activates an inactive relationship. It enables you to use an inactive relationship in a calculation without modifying the overall data model. 2. Useful for scenarios with multiple relationships. Often used when there are multiple relationships between tables, such as relationships on different date columns, for example, order date and ship date. 3. Scope to specific calculations. It affects only the calculation where it is used, allowing you to switch between relationships dynamically. Example 1. Using use relationship with multiple date columns, assume you have two tables, sales and date. The sales table has two date columns, order date and ship date, and you have relationships with the date table on both of these columns, but only one relationship, for example, order date, is active. To calculate total sales based on the ship date using the inactive relationship, you can use the use relationship function. Sales by ship date equal calculate sum sales amount, use relationship sales ship date date. This measure activates the relationship between sales ship date and date for this specific calculation, allowing you to calculate total sales based on the shipping date instead of the order date. Example 2. Comparing metrics with different date columns. If you want to compare sales based on the order date and the ship date, you can create two measures, each using a different relationship. Sales by order date default active relationship. Sales by order date equals sum. Sales amount. Sales by ship date using inactive relationship. Sales by ship date equal calculate sum sales amount. Use relationship sales ship date date. By defining both measures, you can create visualizations that compare metrics calculated using different date columns. Example 3. Filtering based on inactive relationships. You can also use relationship in conjunction with filtering functions like filter or calculate to apply filters based on an inactive relationship. For example, to calculate total sales for orders shipped within the current month using the ship date. Sales shipped this month equal calculate sum sales amount. Use relationship sales ship date dates in period date today 1 month. This measure calculates the total sales for orders that were shipped within the current month, even though the default relationship may be based on the order date. Use cases. Use case 1. Handling multiple date relationships. Use relationship is particularly useful in scenarios where you have multiple date columns, for example, order date, ship date, due date, and you need to switch between these relationships depending on the calculation. Use case 2. Dynamic relationship switching. When you want to perform calculations using different relationships between two tables without modifying the underlying data model. Use relationship allows you to dynamically activate the desired relationship. Use case 3. Custom filtering with alternate relationships. You can apply custom filters based on inactive relationships in combination with calculate, filter, or other functions, allowing for more flexible and targeted analytics. Summary: The useRelationship function in is a powerful tool for activating inactive relationships between tables for specific calculations. It allows you to switch between multiple relationships in scenarios where tables are connected by more than one key, such as when working with different date columns. Use relationship is scoped to individual measures or calculations, giving you the flexibility to work with alternative relationships without affecting the overall data model. This function is especially useful in complex data models with multiple relationships between tables. The user principal name function in DAX is used to retrieve the principal name, usually the user's email address of the currently logged in user. This function is particularly useful in scenarios involving row-level security (RLS), personalized reports, and dynamic content based on the user viewing the report. It enables the creation of dynamic measures and calculated columns that respond to the identity of the user interacting with the report. Syntax DAX user principal name hash name. Key features of user principal name 1. Retrieves current user's principal name. It returns the principal name, typically the email address of the user who is currently accessing the report. 2. Supports row-level security (RLS). Often used in conjunction with RLS to filter data based on the user's identity. 3. Dynamic content personalization. Enables the creation of personalized reports where data and visuals adjust based on the viewer. 4. Integration with other DAX functions. Can be combined with functions like lookup value, filter, and calculate to create dynamic and user-specific calculations. Example 1. Implementing row-level security (RLS). Suppose you have a sales table that includes a salesperson mail column. You want each salesperson to only see their own sales data. 1. Define a role with a filter. Create a new role in Power BI Desktop under Modeling Manage Roles. Select the sales table and apply the following DAX filter. DAX salesperson mail equal user principal name. This filter ensures that when a user views the report, they only see rows where the salesperson mail matches their principal name email address. Example 2. Personalized greeting in a report. You can create a measure that displays a personalized greeting to the user viewing the report. DAX user greeting equal welcome and left user principal name. Find at user principal name 1 and this measure extracts the portion of the user's email before the @ symbol and creates a greeting like welcome, John Doe. Example 3. Displaying user-specific data. Assume you have a users table with columns email, name, and department. You want to display the department of the current user. 1. Create a calculated column or measure. DAX use department equal calculate max, users department, users email equal user principal name. This measure retrieves the department associated with the current user's email. Example 4. Conditional formatting based on user. You can use user principal name to apply conditional formatting in visuals. For instance, highlight rows in a table visual where the owner mail matches the current user. 1. Create a conditional formatting rule. Go to the formatting options of the table visual. Under conditional formatting, choose background color or font color. Use a DAX expression similar to DAX if sales owner mail equal user principal name, light green, white. This will highlight rows where the owner mail matches the current user. Use cases. Use case 1. Row-level security (RLS). User principal name is essential for implementing RLS in Power BI. By filtering data based on the current user, you can ensure that users only see data relevant to them, enhancing data security and privacy. Use case 2. Personalized dashboards. Create dashboards that display personalized information, such as user-specific KPIs, recent activities, or personalized messages, enhancing user experience and relevance. Use case 3. Dynamic calculations. Perform calculations that depend on the user's identity, such as aggregating data specific to the user or comparing the user's performance against others. Use case 4. Conditional visuals. Adjust the appearance of visuals based on the user, such as highlighting data related to the user or changing visual elements to reflect user-specific information. Best practices 1. Ensure unique identifiers. Make sure that the principal names, usually email addresses in your data model, are unique and accurately match the user's login information. 2. Combine with RLS. Use user principal name in conjunction with row-level security to effectively manage data access. 3. Test roles thoroughly. When implementing RLS, test the roles with different user accounts to ensure that the correct data is being displayed. 4. Optimize performance. Be mindful of performance when using user principal name in complex calculations or large datasets. Optimize DAX expressions to minimize performance overhead. Limitations 1. Static principal name. The function returns the principal name at the time of the query and does not change dynamically within a single session. 2. Security considerations. Ensure that sensitive information is properly secured and that RLS rules are correctly implemented to prevent unauthorized access. 3. Compatibility. The behavior of user principal name may vary slightly depending on the environment. For example, Power by Service versus Power by Desktop and the authentication method used. Summary. The user principal name function in DAX is a powerful tool for creating dynamic and personalized reports in Power BI and other DAX-enabled platforms. By retrieving the current user's principal name, it allows for the implementation of row-level security, personalized greetings, user-specific calculations, and conditional formatting. When combined with other DAX functions and properly integrated into your data model, user principal name can significantly enhance the interactivity and security of your reports, providing tailored experiences to each user. The username function in DAX is used to return the domain and username of the currently logged-in user in the format domain username. It can be particularly useful for implementing row-level security RLS, dynamic content personalization, or simply displaying the current user's identity in a report. While similar to user principal name, which typically returns the user's email, username provides the traditional domain username format. Syntax DAX username hashname. Key features of username 1. Returns domain and username. The function retrieves the domain and username in the format domain username of the current user accessing the report. 2. Useful for row-level security RLS. It allows the implementation of security policies based on the logged-in user's domain and username. 3. Dynamic user-based personalization. Similar to user principal name, it can be used to create personalized content based on the current user's identity. Example 1. Implementing row-level security RLS. If you want to restrict data access based on the user's domain and username, you can use username to filter the data. Suppose you have a sales table with a salesperson column that stores usernames in the format domain username. 1. Define a role with a filter. Create a new role in Power BI Desktop under Modeling Manage Roles. Select the sales table and apply the following DAX filter. DAX salesperson equal username. This filter ensures that each salesperson only sees their own sales data by comparing the salesperson fields to the current user's username. Example 2. Display the current user's username. You can create a measure to display the current user's username on the report. DAX currentuser equal username. This measure will return the username of the person viewing the report, such as Contoso John Doe. Example 3. Dynamic greeting based on username. You can create a personalized greeting by extracting the username and displaying a custom message. DAX user greeting equal hello and write username. Len username, find username. 1. This formula extracts the part of the string after the backslash and creates a greeting such as hello John Doe. Example 4. User-specific calculations. Suppose you have a sales table and you want to calculate the total sales for the current user. You can use the username function to filter the sales data. DAX user sales equal calculate sum sales amount. Salesperson equal username. This measure calculates the total sales for the user currently logged in, ensuring that they only see their own sales data. Use cases. Use case 1. Role-level security (RLS) username can be used in RLS scenarios where you need to restrict data access based on the domain and username format rather than an email address. For example, in organizations where usernames follow the format domain username, you can ensure users only see data related to their accounts. Use case 2. Personalized dashboards similar to user principal name. You can use username to create personalized dashboards where the content, KPIs, or messages change based on the logged-in user. This is helpful for tailoring reports to individual users. Use case 3. Displaying logged-in user information in environments where you want to display the currently logged-in user's information in the report for tracking or auditing purposes. Username is the simplest way to achieve this. Difference between username and user principal name hashname. User principal name typically returns the user's email address, for example, user@domain.com, which is often used in cloud-based authentication scenarios like Azure Active Directory. Best practices 1. Consistency in data format. Ensure that the usernames in your dataset are stored in the same format as returned by username. If your dataset stores user information as emails, user principal name would be a better fit. 2. Testing RLS. When implementing RLS with username, always test roles to ensure that users can only access the data they are authorized to view. 3. Use in combination with lookup value. You can combine username with lookup value to fetch additional details about the current user, such as their department, role, etc. from a user's table. Limitations 1. Domain specific. The username function returns the domain and username, which may not always align with the preferred method of identifying users, especially in cloud environments where email is more commonly used. 2. Environment dependent. The behavior of username can vary depending on the environment, for example, Power BI Desktop versus Power BI Service. In Power BI Desktop, it may return the local machine name and username, while in Power BI Service, it reflects the cloud identity. Summary: the username function in DAX retrieves the current user's domain and username in the format domain username. It is commonly used in scenarios involving row-level security, personalized reports, and dynamic content generation. This function is particularly helpful in environments where users are identified by domain usernames rather than email addresses. Combined with other DAX functions, username enables dynamic and secure reporting by tailoring content to individual users and enhancing data privacy. The count rows function in DAX counts the number of rows in a specified table. It is a versatile function used for counting rows in tables, filtered tables, or subsets of tables, making it useful for various scenarios like counting transactions, orders, customers, and more. You can use count rows with simple tables or with tables that have been filtered by other DAX functions, allowing for more dynamic and context-specific row counting. Syntax: DAX copy code count rows. The table or table expression from which to count rows. Key features of count rows: counts rows in a table. It returns the total number of rows in the specified table. Works with filtered tables. You can apply filters to the table using calculate, filter, or other DAX functions, and count rows will return the number of rows that meet the criteria. Versatile in aggregations. It is useful for creating measures or calculated columns that rely on counting rows based on specific conditions. Example 1. Counting total rows in a table. If you want to count the total number of rows in a sales table, DAX copy code total sales rows equal count rows sales. This measure will return the total number of rows sales transactions in the sales table. Example 2. Counting rows based on a filter. Suppose you want to count the number of rows in the sales table where the sales amount is greater than 100. DAX copy code sales over 100 equal calculate count rows sales sales amount is relationship greater than 100. This measure calculates the number of rows where the sales amount exceeds 100. Example 3. Counting related rows in a many-to-one relationship. If you have a customers table and a related orders table with a one-to-many relationship between customers and orders, You can count the number of orders each customer has placed. DAX copy code order count per customer equal count rows related table orders. This measure counts the number of related rows in the orders table for each customer. Example 4. Counting rows in a filtered table. If you want to count the number of rows in a products table where the category is electronics, you can use count rows in conjunction with filter. DAX copy code electronics product count equal count rows filter products. Products category use relationship equal electronics. This measure counts the number of rows in the products table where the category is electronics. Example 5. Counting rows in a time period. You can also use count rows with time intelligence functions. For example, counting the number of sales transactions that occurred in the last 30 days. DAX copy code sales underscore last 30 days equal calculate count rows sales, dates in period, sales day 2's relationship, today, 30, date. This measure calculates the number of sales that occurred in the last 30 days. Use cases. Use case 1. Counting transactions or events. Count rows is often used to count rows in tables that store transactions or events, such as sales, orders, or log entries. Use case 2. Dynamic row counting with filters. You can combine count rows with filtering functions like calculate or filter to dynamically count rows that meet specific criteria, such as counting sales over a certain amount or orders within a specific region. Use case 3. Counting related data in scenarios with relationships between tables, such as customers and orders. Count rows is useful for counting related rows, such as the number of orders per customer. Summary: the count rows function in DAX is a powerful and flexible tool for counting rows in a table. It can be used in simple row counting scenarios or in combination with filtering functions to perform more complex counting operations based on specific conditions. Whether you're counting total transactions, filtering by criteria, or counting related rows across tables, count rows is a foundational function for aggregating data and creating dynamic reports in Power BI and other DAX-powered platforms.